Okay, everybody, we're going to get started again in a few minutes. So if you'd like to come in and take your seats. For COVID safety reasons, we are doing this presentation from a different room within the conference venue. And this session is going to be focused on providing an update on Zebra, which is the Foundation's independent node implementation of the Zcash protocol being built using the Rust programming language. And I'd like to introduce Teor, who is part of the Foundation's engineering team. They've been working with the Foundation now for, 2 years? Before that, they worked with the Teor Foundation, so they've got a long background focusing on privacy and decentralized distributed systems. And Teor is going to give us an update on where we stand right now with the Zebra node implementation and the progress that we've made over the past year. So thank you, Teor.
Thanks, Dodger. I'm Teor. I'm the current Zebra team lead at the Zcash Foundation. And I'm going to talk you through what we've been doing with Zebra in the past year. Just as a reminder, about a year ago, Heartwood had activated 6 months beforehand, and we were in the middle of working on NU5. And so I'll be talking about what's happened since roughly June 2021. So since June 2021, some of these highlights: we have activated NU5 successfully on mainnet and testnet, with Zebra running at the time and processing the activation block and all the blocks afterwards and fully validating all the consensus rules. We've added support for LightWalletD RPCs. So Zebra is now able to be the backend for a LightWalletD server, and then LightWalletD will talk to LightWallet apps themselves. And we've tested that out, and we actually sent the first transaction on the network produced by a light wallet through Zebra about back in May. And that was an exciting moment for us to see Zebra not just download and verify blocks from the network, but actually be able to send transactions as well. As I was saying, we've started gossiping blocks and transactions using the Zcash network protocol in Zebra. So Zebra now has a mempool, which it didn't have a year ago, operating on very similar rules to the zcashd mempool. And Zebra can share transactions with other nodes and help broadcast them across the network. And then when blocks are mined, Zebra can download those blocks and share them with other nodes as well. Some facts and figures: we've tagged 10 alpha and 13 beta releases, which I think roughly means we've been tagging one every 2 weeks. We try to make releases a very routine process so that updates get out to users pretty quickly. We've had a bunch of users testing Zebra and making bug reports, and that's been amazing. And I've been really thankful for users who have been trying out our beta software and letting us know the things that we need to fix with it. In particular, for those releases, we've had 3 different team leads over that time. And so I wanted to give a shout out to Deirdre, who helped us through the mempool and also with their knowledge of zip editing and the consensus rules and the spec have been amazingly helpful. And also Conrado, who did a massive stint of 6 months as team lead and helped us through the end of NU5, the second testnet activation, and all of the LightWalletD work. As part of that LightWalletD and syncing work, we've added extensive tests in Zebra to make sure that all the changes that we're making to Zebra still mean that it can sync with the network and that it can work with LightWalletD. And we've added a bunch of metrics using Prometheus and Grafana, and I'll show you some screenshots of what those metrics look like later on. So as I was saying earlier, back in May, we finished implementing the NU5 consensus rules and a bunch of consensus rules from previous network upgrades. We have a mandatory checkpoint in Zebra that's currently just after the Canopy network upgrade, and we use that to skip consensus rules that have been outdated in a way that's still safe and validates all of the blocks. We've activated NU5 successfully, as I was saying, and we're extensively using Rust. Most of Zebra is written in Rust as a series of Rust crates, and that makes it easy to safely verify blocks and transactions in parallel, to parse data from untrusted peers on the network, and it helps us deliver improved performance and stable verification. In particular, we have a Zebra consensus crate, and that's an independent Rust crate that other projects can use if they also want to verify transactions using the Zcash consensus rules. So here's a screenshot of some of the metrics we have. You can see how Zebra is verifying. You can see the block height that we're at, and then the rates that we're verifying different parts of shielded and transparent transactions. And these metrics have helped us develop Zebra and make sure that it's performing as expected. They're also great for users if you want to see how your node is going. And we've been working with the zcashd team to make sure that we have some similar metrics with the same names in both node implementations. So you should be able to create dashboards that show both nodes and how they perform. So we've done a lot of work on the LightWalletD RPCs. We support the JSON RPC calls used by LightWalletD. I just want to give a shout out to Alfredo, who helped kick us off with the first few RPCs and getting the server set up. And Janito also did some really extensive work on testing those RPCs and making sure that they were working. As I said earlier, Zebra sent its first Zcash transaction to the network in May 2022 via a Light wallet. And it was funny, we almost didn't realize it at the time that it was the first transaction we'd ever sent. We've been doing extensive beta testing. So we have a comprehensive RPC integration test suite that we use to test against LightWalletD. And that makes sure that even if that means we don't have to do a bunch of manual testing, but instead we can run those tests automatically. And then finally, we've been doing some manual testing with the apps themselves to try and find any performance or usability issues that might not be obvious in integration testing. Again, we're using Rust to implement these RPCs, which means that we can safely and efficiently parse the data we get from wallets, even if any user can download a wallet and there might be, say, malicious users who might try and overwhelm the server. We have done some work to make sure that Zebra performs really well in those circumstances. We have an independent crate called Zebra RPC that implements those RPCs. So if anybody else wanted to set up an RPC implementation, say, outside the ZebraD app, then they could do that. So we've also been working on the Zcash network protocol and implementing the parts of the network protocol that Zebra needs to interoperate with zcashd. As I said earlier, Zebra gossips blocks and transactions on the network, syncs up to the tip successfully and reliably. We added mempool support and with protections based on zip 401, just like zcashd. And we can safely and efficiently parse the messages that are sent to us by other nodes or by random people on the internet. And over the last year, we've made significant improvements to the security, performance, and stability of the Zebra network stack. Zebra network is, again, an independent crate, and there are actually other projects that are trying to use Zebra network as a way to communicate with using the Zcash network protocol without having to use the rest of Zebra. And yeah, wanted to thank a bunch of different people on the team for their work on that and debugging and making a huge difference to making the network run very smoothly. The network stack is one of the trickier parts of the Zcash protocol, and so I really appreciate the way that Marek and others have worked very hard on debugging those parts of the system and working out what's going wrong, and then putting fixes in there. So you can see here's a graph of what happens while Zebra is running and the different network messages that Zebra is sending on the network and getting from other nodes. And we've used these metrics to debug Zebra, but also to see what kind of performance we're getting and to see what we can do to improve the network stack. So another thing we've done over the last year is we've made a lot of improvements to diagnostics in Zebra. We've added significant amounts of testing, a full test suite, some tests for building releases, unit tests inside Zebra to make sure all the features we've added in the consensus rules operate correctly. We've added some tests that fully sync the whole chain with Zebra, and those are currently running, I think, in about 10 or 15 hours because of the extra load on the network. But they work well and they help us find out and make sure that any new changes don't break syncing. We also have an automatic merge bot. So that's more of a thing that we do for developers and open source contributors. But it's been amazing to just be able to approve changes and get them automatically tested and merged without a developer having to come back later to check on them. And I really wanted to thank Gustavo, our new DevOps developer, for making that process work so amazingly smoothly. It's been great for the entire team and it saved us a whole lot of work. One of the other things that we've been working on is the Prometheus and Grafana metrics dashboard. I've already shown you 2 or 3 screenshots of those. We have about 7 or 8 different dashboards that you can use in the Zebra repository to show you different parts of the system and how it's working, including mempool, lock syncing, verification, the peers that Zebra is connected to, and the network messages that it's sending. So here's an example of some of the tests that we do. The full suite of tests is actually too big to fit on the screen. But there are extensive tests that we do in Zebra to make sure that what we're delivering to users works and so that we can release frequently and put out updates really quickly. So what's next? I've just told you some of the things we've been doing over the last year. Here are some of the things that we're hoping to do over the next few months or the next year. We want to finish off the beta release series. So at the moment, I think we're on beta 13 or something like that. We don't have a specific end date. We will put out a release candidate when it's ready. We're currently working on some final breaking changes and some final testing and performance improvements. We are looking at getting the Zebra implementation of the consensus rules audited. We've already had a number of reviews of the network code by the Zcash team, and they've been amazing in giving us advice and doing benchmarks and helping us out with that. And it's been great to have people looking at our code and letting us know what we can improve. And yeah, we'll also be looking at, for the stable release candidate series, releasing Zebra binaries, so you won't have to compile it yourself. Some more light wallet testing, some improved user documentation, and then we'll be asking you and different people in the Zcash community to test out Zebra and tell us what we need to improve in the documentation and improve in the app itself. And we're also looking at more features for Zebra. We don't have anything ready yet, but we'd love to know from you what you'd like to see us improve and what you'd like to see us add. Does anybody have any questions? Please post your questions in Discord, and then Jack will ask them.
Yes, the first question has come through from Discord. How feasible would it be to take Zebra's peer-to-peer component and use it as a deserialize, reserialize firewall for Zcashd in front of its C++ peer-to-peer code?
Wow. That's a really good question. So we already do this in our unit tests. So I would say that it's very feasible. You would be able to probably write up something like that in Rust, maybe in a few days, if that's something that you're interested in doing.
What are some ways that the Zcash protocol could change to make Zebra perform better?
Yeah, so there's a few things we've talked about here. So one of the things that we try and do with Zebra is verify as much in parallel as possible, but some parts of the protocol assume that you're verifying blocks one at a time, and so you're required to have the previous block before you can verify the next block. And that means that we can only use one CPU core to verify those parts of the protocol. So one example is in the block header, there is the block history commitment, and that requires that you have all of the blocks before it. If we were to send some components of the block history commitment along with each block, then that would mean that Zebra could verify those in parallel and then verify the block history commitment in series. So that would be an improvement in security for Zebra as well as performance. And but basically anything where we can remove data dependencies would be an improvement for parallel verification in any node implementation, including Zebra.
For developers in the ecosystem who are interested in either making use of the Zebra crates as part of their projects, or who are interested in contributing to the Zebra project, what do they need to know? What are the ways that they can contribute, and what sort of functionality can Zebra provide to other projects today?
So one example, as I said before, of an active project that is ongoing is providing a Zcash network stack. So we have, I think, about 2 or 3 different projects that have been interested in that in different ways. Other functionality is the storage or verification of blocks and transactions if you happen to want to get your blocks some other way and you want some way of storing them with indexing. That's another possibility. And then the RPCs, if you wanted to provide an RPC server based on those stored blocks and transactions, that would be some functionality that you could provide. As to how to get involved, we use Discord. The Zcash Foundation has a Discord server, and that's where we do a lot of our work. On GitHub, we have a project for Zebra that you can join, and anybody can submit pull requests to or open tickets and ask questions. So those are some of the ways you can get involved. A lot of Zebra is written in Rust. At the moment, it works pretty well on Linux and Mac OS, and we're working on getting Windows building again. We've had some problems with conflicting dependencies there. So those are the things that you would probably want to know to get started working on Zebra.
Would it be possible to run Zebra on a Raspberry Pi?
That's a really good question. I don't know what the latest Raspberry Pi specs are. I think the answer is maybe, possibly no. So we're talking memory requirements somewhere in the range of 4 to 8 gigabytes to run Zebra, and I don't know what Raspberry Pis are capable of at the moment. So I wouldn't do it, but if somebody wants to try it out and let us know, that would be fine. But we're generally focused on supporting higher powered desktops and servers as a node implementation, and then supporting lower spec devices via Light Wallet D and other methods that allow apps to be deployed and users to use them that way.
Does Zebra plan to connect to the network via Teor exclusively?
Yeah. So that's a really good question. That lines up with a whole bunch of my interests. So one of the problems with connecting to the network over Tor is that there's about sort of 30, 40 gigabytes of blockchain that you have to download, and that could put a lot of load on the Tor network. And so what we have been thinking about as one of our designs is that, so user transactions definitely require privacy, and we have an experimental Tor integration with Zebra where we can send those transactions over Tor because they're interesting and unique, and finding out where a user has sent a transaction from obviously has privacy implications. But just finding out that somebody is using Zcash or downloading blocks is less privacy sensitive. So we would want to think about the load we were putting on the Tor network. And I know from my time in the Tor project, they would want to encourage people in the Zcash community to run relays to offset the amount of data that we were downloading. So that's what we'd be looking at. We haven't made a final decision, but we are experimenting in that area.
So would it be better, and this is coming from me, would it be better to use Zebra initially to simply broadcast new transactions to the network rather than try to interact fully across Tor?
Yeah, so I think it would, definitely the transactions are the things that you'd want to protect very carefully. And so they'd be the first things that we'd want to send over Tor. And then we want to see how reliable that was and see what kinds of load that puts on the Tor network, probably not very much. And then we'd want to look at adding more and more communication over Tor later on in a kind of staged process rather than trying to do it all at once.
Do you plan to integrate Zebra as a full node backend to full node wallets like ZWallet full node?
We don't have any plans to do that currently, but where we could potentially do that in the future, it's a definite possibility and it could work really well. But we're a small team, and so we're still trying to pick our next few priorities after we get Zebra and Frost finished off and a bit more stable. So that's what we're focusing on right now. But it would be definitely interesting, and we'd love somebody else to try it if you're interested in doing that, and we'd be happy to help out.
What are the biggest challenges the Zebra team has faced in building a node implementation that's fully interoperable with Zcashd?
Yeah, gosh. So I would have to say that Zcashd was developed as a fork of Bitcoin, and the spec was originally developed containing or focusing on the unique rules that were unique to Zcash and focusing on consensus rules. And so we have had to experiment quite a bit when we're looking at the network protocol, which is not consensus critical. And so we have a lot more flexibility in how we implement that. But trying to work out how to download blocks and transactions in parallel and verify them in parallel while still meeting the expectations of Zcashd nodes, particularly the undocumented expectations that they have, has been a bit tricky. And there are workarounds in our code that help us interoperate. But in general, the Zcashd developers have been amazing with answering our questions and have been very helpful helping us diagnose those bugs. So the network protocol has been tricky. Another part that's been tricky is that we have the benefit of having two node implementations is that you discover bugs in the spec. So where one or other of the implementations differs from the spec or from each other, you then have to agree on what the rules should be. And so that has been a bit of a challenge when we've found things not verifying, but it's been great for the ecosystem because it means that we know what the rules actually are. And we're much more sure of the rules now that two implementations have implemented them independently.
What are your impressions of Rust as a language for implementing Zebra?
Gosh. It's amazing. It makes programming parallel code much safer and easier. As someone who has tried to program parallel code in C, it's very, very tricky. Rust doesn't necessarily hide a lot of that complexity, because running things in parallel is tricky, but it does help you work out when it's safe to do that and when it's risky and might lead to security issues. So that's been a big benefit of Rust. The other big benefit of Rust has been a very well-developed standard library. So there are things that we can do and data structures that we can take advantage of that we don't need to write ourselves, unlike a lot of C or C++ code. And then finally, there are entire classes of errors that we just rule out by using Rust. And so there are things that can't happen in Rust where the compiler will stop us before we even run the code. And that is a challenge to learn to start with, but it really helps productivity when you've learned those rules that Rust enforces.
The Zebra team is fully geographically distributed. What are the good and bad aspects of working in that sort of team?
Yeah, so I guess maybe people don't know, but so I'm in Australia in UTC +10, and then we've got a bunch of people in North and South America, and then others are in Europe in UTC +1 or 2, and so yeah, we have a spread of, I think, I don't know what it is, 18 hours across the team or something like that. So it can be challenging to find times for meetings. Most of our meetings with everybody are kind of between 7 and 9 a.m. my time, which is, I think, kind of between 10 or 11 p.m. and midnight European time. So that's a bit of a challenge. And then the rest of the work we do is asynchronous, so I will type things and other people will type things, and I'll get it back in the morning and there'll be a whole pile of messages of everything that everybody's done overnight that I have to catch up with before my 7 a.m. meeting. So that's a bit of a challenge, but it also has huge benefits. It means that there isn't, if this kind of makes sense, there isn't a privileged part of the team that's in the office. Everybody is remote. And so everybody works on the same platforms and does the same things. And it also means that we can take advantage of those time zones, so people will have new work to look at in the morning. There will be time when nobody else is working, when people can concentrate. So there are a lot of advantages to having a distributed team. We've also found out some really interesting things about Zcash network behavior by having people on networks spread across the globe. For example, we know that latency and distance from most of the Zcash nodes affects performance significantly. And we wouldn't have discovered that if we were all in an office next to a data center on the US internet backbone. So there are a lot of advantages to having a distributed team as well.
And finally, what are the best and worst things about working for the Zcash Foundation?
Oh, wow, this feels like an interview. So, gosh, I really enjoy, look, honestly, the Zcash Foundation is probably the best place I've ever worked. I really enjoy how open and honest the communication in the team is, and how collaborative the team is, and how we work together to solve problems. That has been a great experience for me, and how we also get together every few weeks and work out how we could do better and how we can look after each other better. So that's been great for me. And then probably, to be honest, the worst part is getting up at 7 a.m. in winter when it's still dark and cold. I must confess, I've missed one meeting by sleeping through it. And that was, I think, 2 weeks after I joined the foundation, when I wasn't used to it. So yeah, it can be a lot to adjust to and to adjust to remote working, but it also works really well when we make it work.
Okay. Thank you, Teor. We're pretty much at time there, so let's leave it there. We'll be back in 10 minutes in the main ballroom for an update on the Frost